Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So the first thing that I want to mention here is that for the audience already follow me and finished the videos in the past, congratulations, we just finished the first book, or let's say the very first concepts and chapters as a foundation of the geometry for the Olympiad computation. And in the following videos, I will make two series. The first series would be the Pythagorean proposition. It's based on the book written by the Elisha Loomis in 1968. In this book, the author introduced about more than 300 methods to prove the Pythagorean theorem. And I think this is very, very interesting and useful. When we just think of one looks like a simple problem and using different methods and to explore the complex geometry basic or geometry essential concepts inside of it, right? So I think that's very interesting, and because it has more than 300 methods, so it includes lots of different perspective to look at the single problem. I would like to introduce that book to the audience, and so in the videos I will make series video and discuss about the methods. That's for the first series. And for the second series, I will introduce about more than 1,000 theorem that you might be interested in it, right? That's another series. And in between these two, I would introduce methodology of geometry proof. So let's just get started for this series, Pythagorean proposition. Okay, the Pythagorean theorem, I think most of the audience should be already familiar with, and it's just a thing that, for example, we have a triangle here. Let's name it A, B, C, where that angle C equals to 90 degrees. And we can write the length AB equals to C, the length BC equals to A, the length AC equals to B, right? And we want to prove that for any right triangle, such as ABC here, we have A squared plus B squared equals to C squared, right? That's the thing we want to prove, okay? Now we look at the solution. Let's call it solution 1. It's based on the this book, right? Solution 1. The first solution is straightforward, that we make a perpendicular line, or we find the altitude from the edge AB, right? Let's call this point as D. Then we can assume that CD, the length of CD equals to X. The length of DB equals to Y. So we know that the length of AD equals to C minus Y, right? And because the angle CDB equals to angle CDA equals to 90 degrees, and because the angle ACB equals to 90 degrees, that means triangle ABC is similar to triangle ACD and similar to triangle CBD, right? And based on this, we have several different ways to do it, but I'll just write the simplest one. Look at the triangle CDB and triangle CAB, right? So we have A to C, right? A to C equals to Y to A, right? The first A here to C equals 2 y to A, right? That's based on the triangle CBD is similar to triangle ABC. And for the triangle ACD is similar to triangle ABC, we can write the similar equation, which is B to C equals 2. See here, B to C equals 2 C minus Y to B to C, right, equals to C minus Y to B. Which means we have A squared equals to CY and B squared equals to C squared minus CY. Which means A squared plus B squared equals to CY plus C squared minus CY equals to C squared. Okay, so this is the shortest proof for the Pythagorean theorem. And you can use different ways of the ratio of the edges to do this proof. Not necessarily by this one, but this is the simplest solution so far. Okay, that's for the solution 1, and we will introduce the rest in the future videos. I hope you like this one. See you in next one. Thank you.